Okay, hi guys. So we're going to be looking at the first topic in P2. P2 is electricity, and we're going to be looking at Ohm's law, which is a law and an equation you have to learn, and I'll teach you that and go through that. And then we're going to look at the required practical, where you understand and investigate Ohm's law. So the pages you see in front of you on your revision guide. So we're doing these two bits: Ohm's law and your required practical. Okay. So let's go through some basics. If you look on the screen, I've set up a circuit here, and this circuit, I've got a couple of cells together making a battery. I've got my wires, these things here are my wires. I've got a resistor in there, okay, and then an ammeter, and I've got a voltmeter here. So let's have a look at what's happening. This is these little negative charges are the electrons. And electricity is made of electrons. The electrons are flowing around the circuit, and I need a complete circuit for the electricity to flow. Look, if I break the circuit by doing that, you see the electrons can't move anymore, and it's stopped, and the electricity stops. So I need a complete circuit. First thing with electricity, I can join the circuit back up again, and around they go. I've got three quantities I need to be aware of: voltage, current, and resistance. Right, let's take a look at each one of those things. The voltage, sometimes we call potential difference of voltage, comes from the cells, these two cells together making a battery. So let's have a little look at what happens. If I hover over my battery, I can change my voltage. I've put it on a random number at the moment. But look at the electrons. Just watch the electrons flow. I'm going to turn the voltage up. You see what's happened to the electrons? Higher voltage. Electrons have got more energy. Okay, you can see them going faster. They've got more energy. Turn it down, look, the electrons are going slower. Okay, so one way of thinking of the voltage is how much energy the electrons are being given. If they've got more energy, you see them flowing faster. Now, when they flow faster, that flow of charge, the flow of negative electrons, we call the current. Okay, and look, here's the current, and I'm measuring the current with my ammeter. So an ammeter measures the current in amps. The voltage comes from the battery. Voltage is measured in volts. The ammeter is measuring the current in amps. So again, if I turn my voltage up, look what happens to the reading on the ammeter. Look, here's my ammeter here. Look what happens to the reading on the ammeter. More voltage gives you more current. Yeah, more electrons got more energy, faster, so the current is higher. Okay, right. Last little thing. So that's my voltage. How much energy I'm giving to the electrons. Give them more energy, they go faster. More voltage gives me more current. Let's have a look at this thing here. This is a resistor. Resistance is what slows the electricity down. Okay, it's like trying to drink milkshake through a straw. Imagine you're trying to drink a McDonald's milkshake or whatever milkshake through a straw. If you've got a big wide straw and you suck on the milkshake, it comes through quite easily. There's not very much resistance. If you've got a narrow straw, it's harder to suck the milkshake through it, and you get more resistance. It's harder, and so the milkshake comes through slower. And that's what's happening here. Let's have a look at the resistance then. Look at the flow of electrons, my current. Okay, if I turn my resistance up, look what happens. Look, they slow down. More resistance, just like trying to get the milkshake through the straw. I've made it harder for the electrons to get around the circuit. Okay, there. So we've got three quantities. We've got voltage, volts, current, which we measure in amps. Look, there's an A there. And we've got resistance, and the resistance we measure in something called ohms. If you look on the thing there, look, ohms. That's what we measure resistance in. V for volts, current in amps, and we give current the letter I, which is confusing, and I'll show you a bit more in a second. And resistance is R, measured in ohms. And if I what I can do is if I break the circuit, it's going to look a bit messy, but I'll put a light bulb in. If I put my light bulb in there, and there it goes. And if I make the resistance more, the light bulb doesn't light up. I've done something stupid and not put the light bulb in properly, I think. Oh, hang on. That's why. I've got to break that. And then if I cut that and put it so one there, because the electricity's actually got to go through the light bulb. There you go. And there's my light bulb. Look what happens when I change the voltage. So if I make my voltage less, look, the current goes slower, look, and the light bulb gets dimmer. So look, high voltage, faster current, brighter light bulb. Low voltage, less current, slower current, dimmer light bulb. Let's do it for, let's leave the voltage in the middle. Here's my resistance. Remember, resistance is what slows the electricity down. More resistance, the current goes slower, but the light bulb gets dimmer. Less resistance, current goes faster, the light bulb is brighter. So the voltage, the current, and the resistance are all linked. When I'm explaining to younger children what voltage is, so you say the voltage is like the battery pushing the electrons. The more voltage, the more push they get, the faster they go, and that's the current. And if I slow them down by making them go through a component that's got more resistance, harder to get through, the current will slow down. Okay, V, I, and R. V, voltage, I, current, R, resistance. Now, V, I, and R are linked, and this is the first bit of the lesson. The first bit of the lesson is to do with what we call Ohm's law. And Ohm's law we represent with an equation. And here's the equation here. The potential difference or voltage, we sometimes use those phrases interchangeably to mean the same thing. There is a difference, but we'll worry about that later. Here's my voltage. Here's my current. Here's my emails. Here's my resistance. So voltage in volts, current in amp, resistance in ohms. They're linked together in this equation. We call this Ohm's law equation. And what does it mean? So let's look at this simulation here. Here's my Ohm's law equation. Okay, V is voltage. I is current in amps. Wouldn't it be handy if it was a C for current or an A for amps? Well, it's not. Someone's used C and A for something else. We've run out of letters. We're calling the current, we're giving it the letter I. Okay, and R is my resistance. Remember, volts, amps, current, ohms, resistance. Well, with this, the three things are linked. V equals IR. The voltage is equals the current times the resistance. So if I make my voltage less, the current will get less. If I make my voltage more, the current will get more. It's just the same as this one. If I make my voltage more, okay, the current will go faster. It goes more. The bulb gets brighter. Okay. Here's my other one, my resistance. So resistance, remember, makes it harder for the electricity to get around the circuit. So I'm going to make my resistance more. My current will get less. I will get less. Make my resistance less. Current will get more. And it's just the same. Let's look at the circuit. If I make my resistance less, look, current goes up. See how I went up. I make my resistance more, and current will go down. There you go, it's gone down. So you have to remember this equation, right? V equals I times R. Okay, V is your voltage, volts. I is your current in amps. And R is your resistance in ohms. Now, you will have to rearrange this. And a lot of people, myself included, actually remember it in a triangle. V, I times R. And let's make a triangle there again. Okay, now the one you want to, in the questions, it will give you two of those things. It will give you V and I and you have to find out R, or it will give you R and V and you have to find out. It will give you two and you have to find the third. The one you want to calculate, you cover up. So if I say, I want to know what the current is I. Okay, so let's cover up I. So the current is V divided by, that line stands for divided by R. Okay, if I wanted to figure out V, it would be I times R. You cover up the one you want and then you can figure out the third one. And it's as simple as that. But the reality is VIR, you've got to remember it. It's not on your equation sheet. So you have to remember that. Now, you do a required practical where you have to, you're kind of proving Ohm's law almost. And you have to set up a circuit and you have to take different voltages and currents and work out the resistance. So you're using V equals IR. Just another email. I should turn them off, shouldn't I? So here's the circuit you set up. Now, it is very similar to this one. Look, I've got my batteries, I've got a wire, I've got a resistor, I put a bulb in this one, and we've got a bit of resistance wire here. This is wire. I've got my ammeter. I've got my voltmeter. It's very similar, but it looks slightly different. So let's go through it. Here's my wire. Now the wire is taped onto a ruler. And the reason for that, there's two reasons. One, because you're going to have to measure lengths of wire. So you've got your ruler to measure with. And two, the wire could get hot. So by taping it to the ruler, you don't have to touch it, even if it's hot. Okay, here's V, here's my voltmeter. Here's A, here's my ammeter. Here's my cells, which together make a battery. And here is my switch. Now, in a nutshell, all you're going to do is you put your crocodile clips onto the wire. That completes the circuit. Let the electricity goes from the battery, through the ammeter, through the crocodile clip, along this wire, out this crocodile clip, along this wire, and back to the battery. If the switch is closed, that's a complete circuit. Okay. Now you can change how much wire the electricity goes through by moving the crocodile clips. You could do like a short gap, or you could move this crocodile clip right down here and you could do a long gap. If I was doing it on here, look, I could measure the voltage over like this bit of wire, and I could have the electricity going through this bit, or I could move my crocodile clip just down there. The crocodile clips you can move where they are. Okay, so you set your circuit up. Here are my crocodile clips. I close the switch. The ammeter, the electricity will flow. You measure the current in amps. You measure the voltage in volts, and you write it in a table. Switch off quickly. Now the wire will get hot, and the temperature will affect the resistance of the wire. So you want to, the control variable, one of the things you want to control is the temperature of the wire. And you do that by switching on and taking a reading quickly so it doesn't have time to get hot. And you do it by letting the wire cool down after each reading. So you want to control the temperature. If the wire gets hot, it's harder for electricity to get through the wire. Have you ever played crazy golf, where you putt a golf ball, and one of the holes is a windmill, and you have to putt the ball between the blades of the windmill. If you imagine if you're doing that, if the windmill's spinning faster, it's harder to get the ball through. If the wire is hotter, it's harder for the electrons to get through the wire, because, you know, if a hot solid, the particles in the solid are vibrating faster. It's harder for the electrons to get through. So if the wire's hot, it's harder for electrons to get through. The resistance is higher. So we've got to control that and keep it the same. We keep it the same by not leaving the electricity on for very long, do our reading quickly, and by letting it cool down each time. So you do that, you read your current and voltage, you write them down, and then you do a longer bit of wire. Switch back on, do your current, your voltage, write it down, and you end up with a table where you've got the current, the voltage, and the length of wire. Okay, and then for each current and voltage, you work out the resistance. So you know the resistance for each length of wire. Okay, and what you'd find is this. Look at this graph down here. Look, you calculate the resistance, voltage divided by current. Remember our triangle? I'm calculating resistance. So it's the voltage V divided by I. I know my voltage. Look, so I've got my voltmeter. I know my I, my current, because I've got my ammeter. I calculate the resistance. I know the length of the wire. I know the resistance. And here we are. I plot a graph. The length of the wire versus the resistance. And look, as you'd expect, the longer the wire, the more resistance, because there's more particles that the electrons have to get past. It's harder. It's like you trying to get down a longer corridor. It's going to bump into more people. It's going to slow you down more. Okay. So just to recap then, there's two things you've had to learn this lesson. Okay. The Ohm's law. Okay. You've got voltage, current, and resistance, and they're related. And they're related by this equation, V equals IR. We put it in this triangle because that helps you rearrange it. If you know two things, you can find the third. You've got to know voltage is in volts. Sometimes we call voltage potential difference. You need to know current is in amps. In the equation, we give it the letter I. Confuses everybody. We just accept it. And we know resistance is measured in ohms. Okay. Remember, the bigger the voltage, the bigger the current. The bigger the resistance, less current. Okay. And you can just picture the electrons going around the circuit. If you could give them more energy, they go faster. More voltage, they go faster. More resistance, they go slower. And how fast they're going, kind of, is kind of the current. And that's a way of thinking about it. Get off. Okay, so what's happening? Okay. So then, to show Ohm's law, we set up this circuit. Okay, you've got to know your variables, your independent, dependent, and control variable. The independent variable is the thing I'm changing, and the independent variable, what you're changing, is the length of the wire. You're doing it for different lengths of wire. Control variable is what you're keeping the same. The control variable, you're trying to keep the temperature the same, and you're using the same wire each time. Okay, and the dependent variable, what you're measuring the voltage and the current and working out the resistance. You could say the resistance is the dependent variable. You could say the current and the voltage is the dependent variable. Okay, right, I'm going to put some questions so you can check that out. It's basically all, if you're doing trilogy, it's all on page 180 of your revision guide. If you're doing separates, it's the same, but it's probably not on page 180. Look it up, learn the equation, learn how to do the required practical, learn what your variables are. Good luck. Okay, thanks for listening.